recall that if we have two vectors, v equals to x1, y1, z1, and you have a second vector like w with components x2, y2, and z2, we can construct a dot product. The dot product is defined as what we saw before, is x1, x2, so we multiply the corresponding components and add them together. y1, y2 plus z1, z2. This is always a number. The outcome is always a number. Well, it turns out we can write the angle between two vectors using their dot product. The cosine theta, theta is the angle between two vectors, v and w. This is the angle. Is equal to the dot product between these two vectors divided by the magnitude of the first vector times the magnitude of the second vector. Again, recall that the magnitude of vector v is the square root of x1 squared plus y1 squared plus z1 squared. And the magnitude of vector w can be calculated using x2 squared plus y2 squared plus z2 squared. So cosine theta, theta is the angle between these two vectors, is equal to the dot product divided by the magnitude or norm of each of those vectors. We're going to use this to find the angle between two planes. There you go. So last time we talked about relation between two lines in the space. We said that if you have lines like L1 and L2, they have the following relations between them. You either have parallel lines, it means that L1 is parallel to L2. It means that their direction vectors, those are having a relation together. Here you have V1 and V2, the direction vector. V1 and V2. They're parallel to each other. So when they're parallel to each other, it means that the angle between them is equal to 0. When theta is equal to 0, cosine of theta is cosine of 0 or equals to 1. It means that when you construct the angle between them, cosine theta, which is V1 dot V2 divided by the magnitude of V1 times the magnitude of V2, this is V1, V2 is nothing but the multiplication of their magnitudes. The angle is 0 and cosine is equal to 1. This is the relation that you can actually find between these two vectors. They are scalar multiplication of each other, or they are intersecting. They are intersecting. So it means that you have line L1 and line L2. There's a point of intersection between them. You find that point by solving the system of linear equations. A, B, C. This is what we did before. Between two lines. Now we have planes. What's the relation between lines and planes? So when it comes to lines and planes, they have the following. You either have plane here with normal vector n. So remember that when you have a plane, you need to identify that plane by its normal vector. It must have a normal vector. And this is your plane. Then you have a line like L1, and that line is actually parallel to your plane. So line L is parallel to the plane. Line L is parallel to the plane. So it's parallel to the plane. What's the relation between the line and the normal vector? They are perpendicular. So L is perpendicular to N, the normal vector. L is perpendicular to the normal vector N. What is the angle between them? Theta is pi over 2. So if you construct the dot product between them and find the cosine of pi over 2 is equal to 0. So 0 is equal to, so let us use V as the direction vector. It makes it easier for us. Direction vector V representing your line. 0 is equal to V dot N divided by the magnitude of V times the magnitude of N. This is equal to 0. It means that the dot product is equal to 0. So N dot V is equal to 0. You might have your line actually crossing the plane. So this is parallel, and now you find that the line is actually crossing your plane. This is your normal vector, and this is your plane. And here you have your line. Well, our line actually crossing the plane. So there is a point of intersection between the line and the plane. Point of intersection. Line L crosses the plane. And the point on the line and the plane. So this point belongs to the line. It satisfies the equation of the line, and at the same time, it satisfies the equation of the plane. So you have two nice equations to find the coordinates of that point. And finally, your line is entirely on the plane. So this is our plane. This is the normal vector of the plane, and this is your line. Line L is entirely on the plane. Line L is completely on the plane. So these are the different cases, different relations between lines and planes. Perfect. Let's go over one example together. This example says, find the point at which, find the point of intersection between the line x equals to 2 plus 3t, y equals to negative 40, and z equals to 5 plus t, and the plane, the equation of the plane is given to us as 4x plus 5y minus 2z equals to 18. We have a plane, we have a line, and the equation of the line is given to us as a parametric equation. So x is 2 plus 3t, y equals to minus 40, and z is equal to 5 plus t. We want to find this point. What is the coordinates of this point? Again, note that this point is on this green line and on this plane. At the same time, the coordinates of this point satisfy both of these two equations. So the point of intersection x sub 0, y sub 0, z sub 0 satisfies both equations. So what is the first equation? You have a parametric equation. X sub 0 is equal to 2 plus 3t. Y sub 0 is minus 40. And z sub 0 is 5 plus t. And for x sub 0 plus 5 y sub 0 minus 2z sub 0 must be 18. Two equations, parametric set and the plane. Well, okay, they have 1, 2, 3, 4 variables, but note that each one of these three variables are written in terms of the fourth variable. So since you have a nice relation between them, just substitute all here. Then we get one equation with one variable, and then the rest is easy. So we have 4 times 2 plus 3t plus 5 negative 40 plus, minus 2 times 5 plus t equals to 18. T is equal to minus 2. Okay, I have t equals to negative 2. I can get back to these equations and write the coordinates of the point. So x sub 0 is equal to 2 minus 6, negative 4. Y sub 0 is equal to 8. And z sub 0 is equal to 3. So the point, this point has coordinates negative 4, 8, and 3. Point of intersection. Negative 4, 8, and 3. Well, now I expect you to ask, what if I have two planes? What is the relation between two planes?